Hey everybody, this is a video about the second law of thermodynamics as it relates to Viktor Schauberger's hypotheses and ideas, and about the second law in general. It's specifically a video for the people in the Viktor Schauberger group, or in a particular Facebook group about Viktor Schauberger, and it's also, of course, for the general internet at large. If you don't know who Viktor Schauberger is, just look him up on Google and read some of the bios and whatnot about him. He was a scientist from the past who was very, very interesting, very, very clever. So let's dive into this subject. Many people watching this video are engineers and scientists, very likely, and so they probably know what the second law is and have a good idea of it. Some people may not know a lot about it, and some people may have no idea. So let's give an analysis of the second law of thermodynamics, or a presentation of it, so that anyone can understand it super easily. And if you already know what it is, just skip through this. So the old classical version of the second law of thermodynamics was developed on the basis of heat engines and the behavior of heat and cold generally, and it could be stated as a universal rule that might go something like this: the amount of entropy in a closed system cannot go down over time. It cannot go down over time. However, and you could define entropy as the amount of energy in a system that cannot be used for work. The measure of energy in a system that cannot be used for work. So this is like a definition. It's like an academic definition you could use, but it doesn't really mean that much, very likely, to most people. So what we want to do is have a more practical definition, or not a definition per se, but a practical working out of what this might mean in everyday life. So a good example would be a teacup. You pour hot water into a teacup, and the hot water is not going to gather heat from the room and begin to boil. It's not going to go down to like minus 500 Celsius or something like that spontaneously. It is going to cool off, and the room is going to heat up a little bit, and the amount of the differential between the room and the coffee cup or teacup or whatever it might be is going to decrease. The difference between the two things is going to decrease, and the difference between them is what you could use for work. So, for example, if you could put a Stirling engine between in the conjunction of the two temperatures, or the areas with the two temperatures, and make them do work on it. Or in it. So this version of the second law is not exactly what is really believed today in academic science, this absolute rule about heat. The version that you would get taught in a more advanced course on thermodynamics is a statistical version of the second law. So the statistical version is not an absolute. It doesn't say that the coffee cup could never heat up under any circumstances, or that an individual particle could never heat up, or whatnot, an individual collection of atoms. Instead, what it says is that this is very unlikely to happen to any high degree. So it's a statistical claim, basically. Now, the way that this could be visualized as working out in practice is that if you take a jar of marbles, like with, let's say, half the marbles being red, half the marbles being blue, and they're stacked on top of each other, so they're divided into different layers. There are way more ways, if you were to jostle the jar, shake it up, or do something to it, there are way more ways for to create, with respect to the color of the marbles, to create a depolarized condition closer to equilibrium than there are ways to create a stratification of the marbles. So that's like pretty clear. So since we now kind of understand the second law a little bit better, and we might have an intuitive grasp of it, the obvious question is this law, which is kind of taught as gospel in conventional science, is it applicable to the whole universe? Is it true? Is it some kind of absolute in a statistical sense? This is how reality works. And as a matter of fact, it is not. It doesn't really make sense to apply the law to the whole universe. It is something that will cause us to run into contradictions. and problems. So the first problem that we're going to run into in trying to apply the law to the universe is the fact that we don't actually know in the broader scope of tiny atoms, of huge galaxies, of ridiculous lengths of time, if there are, in fact, a ton of high entropy states. It could be that there are contexts in which, in the whole of the universe, that there are many contexts in which there are many more low entropy states, so that are actually physically possible. So now this doesn't necessarily in itself rule out the second law, the statistical second law as an idea, but we don't have any experimental evidence or direct empirical evidence of any kind that this arrangement that the law kind of demands is actually true of the universe. And when we get to the next point, we're going to see why contradictions are going to inherently arise if we want to say that this relationship actually does, or that this attribute of the universe is actually there, that there are all these super high entropy states that are possible, or much relatively higher entropy states that are actually physically possible. So there is very evidently useful energy in the universe. There's tons of it. You can lift up a table, you can lift up a chair, you can go jogging, you could burn firewood. There's tons of useful energy. So where did this useful energy come from? And there are straightforwardly only two answers in relationship to thermodynamics. Either the second law of thermodynamics is wrong and sometimes entropy is undone, or, on the other hand, the first law of thermodynamics is wrong and energy can be created from nothing. Now, the first law, which is not even a law of thermodynamics, it's a kind of axiom about the universe, I would highly doubt that it's actually wrong. I don't think you can create something from nothing. There were sort of complexities you can go over about potentially energy not being a constant per se in the universe, but they're not worth going into in this context. We're not probably seeing energy literally or arise out of nowhere, just being created and created and created in order to satisfy this. So this is not really a possibility. So we have to naturally get to the idea that since we're far away from the absolute highest statistical entropy that is possible, or even one of the higher states of entropy that's possible, given an infinite amount of time, that the second law must be wrong. And there are ways that people try to get out of this predicament. So in the past, something would be said like this. People would say that the universe actually is in as high an entropy state as possible, and what we see of the universe is like this kind of emergent thing arising out of the sea of maximum entropy and equilibrium. However, this runs into huge problems, because if this idea is being accepted as a possibility, as an explanation, we have to also accept the fact that it's much more likely that just a person or a brain that's hallucinating a world, or just our planet would pop into existence or would arise spontaneously out of this sort of sea of chaos and entropy. No scientist wants to think that that's going to be the case, and so because that's even more likely than the visible universe arising in this way, we have to throw out the idea. So the universe isn't in a maximum entropy state at all, and or doesn't, at least it seems like we don't want to say what we would have to assume that that's true. So we've got to move on to the next or thought process that is used to try to get away from the second law not being true. So the next thought process that is utilized is the idea of the Big Bang theory. People say the Big Bang began, or the universe began with the Big Bang in a state of low entropy, and now it's moving towards a state of high entropy, so you put in the conditions of low entropy in the beginning. Now, the problem with this, there are two problems. For one, if we take the Big Bang theory at face value and just accept it, it still doesn't answer the question, because you are still having to basically come back to the same problem in a different way. So there still are only two ways for there to be this low entropy condition. Obviously, you can create the energy from nothing, or you can have the second law be run backwards. Now, people say, well, time began at the Big Bang, so entropy, or the second law of thermodynamics, relates to time, and because there was no time at the beginning or before the beginning of the universe, if that even makes sense, different ideas apply. But on a surface, sort of straightforward approach to the Big Bang theory, this is not actually how things are working. So the Big Bang theory, as what you might call an observational idea, and we're going to get to the subject of whether it is or not, but as an observational idea, it has nothing to say of time beginning or of any of this stuff. It just says or the deductions from the observations would just say that the universe was more dense, and so you're still back at the same problem. You are just pushing the problem back. Now, so you can't have time begin and all this stuff. That's just like all models. That's not even a deduction based on the evidence. So aside from that, the Big Bang is actually bullshit. The universe probably existed forever, and a reasonable scientist would just assume that it most likely did exist forever because there's no reason to have a Big Bang. The Big Bang theory is based on the expansion of the universe, which is posed on the basis of deductions about the appearance of light coming from distant galaxies, and planets, or not really planets, although it's probably coming from there to some degree, but distant stars and distant galaxies. And these deductions are not the sort of deductions that we should be making because we don't have any contact with what it would be like physically going on in huge distances of space and massive gas clouds and gigantic plasmas and galaxies spinning around. We don't know what light does in that context, so it's ridiculous to make deductions about it. We should just forget about the subject and recognize that it's sort of a religion. It's sort of like if you were to say we should base our biology on the evidence for the resurrection of Jesus Christ, because there is some evidence that you can use to deduce that. Well, no, because we don't have any experience to deal with that kind of thing, and so it doesn't make sense as a basis for any scientific knowledge. So the Big Bang theory fails in multiple ways. Now, there is actually direct evidence, aside from the contradictions involved in asserting the second law. There's direct evidence of it not being correct. There are experiments you can do, but I'm not going to get into those in this specific video, but a more tangible example that anybody can see is the example of stars. So stars, when they form, they concentrate from a background of plasma and diffuse gases, and they concentrate down into something that's very polarized from its surroundings. You have the voided surroundings and the super concentrated star, and people try all kinds of mechanisms to try to get away from this fact, but it is a fact that is an obvious violation of the second law of thermodynamics, unless maybe it's running in the opposite direction and it's the stars are turning into gas and no stars are forming, but nobody thinks that. So, and you know, that would obviously bring us back to other problems. So the second law can be seen very clearly to be false. In a broader sense, or seemingly false, at least, like it appears not to be true. And whatever is, we don't want to make assumptions about gravity, but what people call gravity, the way it behaves in outer space, that process violates the second law because it concentrates things. If there were, you know, in the teacup thought experiment, it is actually making the teacup heat up, in quotes, although it's not necessarily heat. It's making it heat up spontaneously, or it's making the room cool down spontaneously. So the second law, these arguments they can't be gotten around. Like, we would have to advance much further in order to scientifically, in order to refute what I'm saying and say that the second law is true. And in fact, the second law has been holding us back because it very well may be possible to create machines that will polarize, say, air or water or many other media, and you know, be able to draw or be able to create a condition in which we can harvest the naturally surrounding energies. So because machines may be able to polarize the energy in a medium, we could have unlimited energy for everyone. We could be able to do that for real. And all we'd have to do in order to have a plausible candidate for a machine that could do that is to replicate natural phenomena that very well may not obey the second law. So we would replicate stars, galaxies, huge ecosystems, things of that sort that haven't been studied in relation to the second law very well, insofar as like an experimental analysis. Because I do know, obviously, the second law is true of engines, conventional engines, and true of teacups and stuff. You'd have to be a lunatic to think that it's wrong in those cases. But in cases where it really hasn't and can't at present be studied that well, if we replicate those circumstances, then we very well may be able to come up with something that is pretty impressive, which would be very much needed by humanity because we're in a desperate circumstance at the moment. People are suffering badly. The planet is suffering. The world is basically being turned into dust. The powers that be, the elites, the government, the corporations are making a profit or trying to scavenge a profit from the bones of a dying world, and we've got to change things. Now, none of this is implausible or crazy or insane. It's perfectly reasonable to think that some process we haven't looked into that much might be able to run entropy backwards. There's nothing at all wrong with that. There's even further evidence, which I won't go into in this video, which supports it. However, when you present these ideas, as Viktor Schauberger did, and don't make any apologies, basically, you say it's pretty much bullshit. Like, there isn't any extremely compelling reason to believe that stuff. It's just that it's been taught repetitively for years. There's no reason to believe in the second law. There's no reason to hang on to the Big Bang, and we should try to manipulate and engage with phenomena that may contradict these ideas. People say that you're so disrespectful, you're so arrogant, you shouldn't assert that basically that academicians today are kind of stupid or kind of like maybe intuitively brain dead. People say you just shouldn't say things like that because it's mean, it's hurtful, it's inflammatory, it's pseudoscience, it's all this stuff. It's like yada, yada, yada. But the fact is, number one, if you're into Viktor Schauberger, if you're into Tesla, these people were inflammatory and pseudoscientific in the modern way these people are using it, and they were not kind people in this sense. They attacked their enemies. They said that modern science was bullshit. Tesla made a poem about how Einstein was a long-haired crank. So if you're into these people, you shouldn't get mad at me for saying similar things to what both of these guys would have said in the first place. And then secondly, we don't have time for the sensitive little feelings of academics with their awards and Nobel Prizes and their accolades and their honors and their ego stroking. We don't have time for any of that. Like, I'm not intentionally rude to anyone, but like, look at the second law. Now, I don't know with absolute certainty that it's false. It seems like it is. It's false that I'm pretty much certain it's false that you cannot create what would be called a free energy device. Like, you definitely can. Such things exist in nature. They're called stars. So there are such things as free energy devices, and a law or an interpretation of a law that gets in the way of people doing that, at a human level of creating these kinds of things, it's pretty stupid for someone to believe in that. There's something that is actually wrong with your mind if you cling to that. And I'm sorry for being rude, but there's no other way to say it. Like, how is it that you can justify in your mind there being this universal statistical rule that has not been tested in the context in which it would be important to test it as a universal statistical rule, because humans can't test it in those contexts, and a rule that is, why would you want to hang on to something that's basically very likely holding us back? Because, in your heart, I could be right. It could be that the second law actually is not correct, and that you can polarize media and draw off power. So that could be correct. There's nothing logically or experimentally that says that it's wrong. People turn to they'll say things like, well, all the experiments ever done prove the second law, but those are just a tiny number of experiments, and they're compared to the whole universe, and they're all largely pretty similar. Try to do an experiment with a whole forest, an entire forest. Try to do an experiment with a star, a galaxy, a tornado. See if that obeys it. And things you can't easily do experiments with these things. But you can replicate their geometry. You can replicate the way electricity flows in them, and it's something that's worth exploring. So I don't mean to be rude, I don't mean to be inflammatory and pseudoscientific, but there are very few people who understand the subject as well as I do, and I'm not saying this because I'm super smart or anything. It's really because most people just believe the second law, and I believed it. I believed it at a younger age when most people probably hadn't thought about it. But when I looked into it with a thought process of trying to disprove it, because I've always been a skeptic, and I looked into it, and it is easy to show that it is not that tenable, and that it's foolish for just stupid apes like us to have such an audacious and outrageous and ridiculous law and apply it to all of reality, and yeah, just holding us back. So fuck the second law, throw it into the trash can. I don't mean to be rude and inflammatory, but we're in a very serious condition in the world, and we've got to throw out academia altogether and have a new way of doing things entirely. So post comments on what you think about the second law, what you think about this video. I'm happy to entertain actual arguments, not just one-liners like, you didn't debunk the second law, and then like snide comments. But I'll probably just insult you if you do that, to be honest. But if you have an argument, I'm happy for people to disagree. I'm not, as I said, the smartest person in the world. I don't know everything, so feel free to disagree. The only way that my argument and that my argumentation could get better and can get better, and that I can expand my horizon, is if people argue with me and present opposing views, even if they're not correct, or even if you don't feel confident. I won't be unkind to you if you just present like a genuine opposing argument. I really want to entertain all this stuff and move forward towards truth to, all together, but people have got to stop being triggered about the poor, precious little feelings of the academicians, because those people are largely parasites and leeches that are draining the public purse through the government and self-aggrandizing themselves and the very state that funds them. So I'll talk to you all soon, and I wish you the best day ever.